Hello, welcome to lesson 8.3. So we're going to continue on with our circle geometry. At this point, you should have done the tangent properties as well as the chord properties. Tangent lines being lines that are outside of circles, chords being lines that are inside circles, connecting two different sides of the circle usually. Tangent lines only touch the circle once. Today, what we're going to do is we're going to talk about angles. So we're going to talk about inscribed and central angles inside of circles. We're going to start off with a few definitions here. So we're going to start off by talking about an arc. An arc is just like a section of the outside of a circle. So for instance, if I just randomly had a circle, let's draw one right here. If I just picked a point right there, and I picked another point right there, the distance between those two right here, I should probably use a different color than red. That distance is an arc. Whenever you have an arc, you have the arc that connects the 2 points in one direction, and then an arc that connects the 2 points in the other direction. So if you look, I still have those same 2 points. I could technically connect those points all the way around here to create another arc. But it's still connecting the same 2 points. You'll see you have one arc will always be bigger, one arc will always be smaller. The smaller one is called the minor arc. The bigger one is called the major arc. So it just depends if you're going like the long way around from one point to the other or the short way around from one point to the other. If you look over here, they've drawn a nice little picture on the right-hand side. They've given you 2 points, A and B. The short distance from A to B is called the minor arc. The long distance from A to B would be all the way around here, would be called the major arc. Perfect. Couple more definitions. When we start drawing lines inside of this circle and we're going to connect points on the arcs, we're going to get 2 different types of angles. We're going to get central angles and inscribed angles. We'll look at this picture right here. Okay, so we have 2 points on the outside. We have point A and point B, which gives us 2 different arcs. We have this big major arc all the way around the outside. That would be my major arc. Or we have a minor arc right on the inside, like that. Perfect. If you look at points A and B, you'll notice that there's lines that go from A to B. So for instance, I could have gone to the middle and then to B. Sorry, I just had a computer problem and we are back now, so it might have sounded a bit like jaggedy in the middle of that video. What we had here was we had a circle. We had points A and B. We talked about their major arc, their minor arc, and now we're talking about other ways that points A and B are connected. So if you look at that green path that I drew, you can see point A and B are connected by going to the center of the circle first and then going to point B. They're also connected another way if you went from point A and you went all the way out to point C like this through the chord. And then you went back to angle B, or point B, sorry, along this chord, you could connect A and B as well. And when you connect points A and B in those 2 different ways, we have the green way and the blue way, we create 2 different angles. So the first way is by going through the center of the circle. We created this angle right here. That is called the central angle. The other angle that we created from going A to C to B is this angle right here. We call that the inscribed angle. And we're going to learn a little bit more about central angles and inscribed angles. All you need to know for now is the definitions of them. The central angle is the angle created by going through the center of the circle from one point to another point. The inscribed angle is the angle created from going from a point to a point on the outside edge of the circle to another point. So A to C to B. Awesome. For one more time, I just want to talk about this right here because you're going to have to see that notation. That means angle A to O to B. So it's the angle created when you draw a line from A to O to B. If you were to read this one right here, that reads as angle A to C to B. So it's the angle created when you go from point A to point C to point B. Awesome. Definition, I don't use it very often, but the inscribed and central angles in this circle are subtended by the minor arc AB. That means if you were to connect A and B, you get this arc right here, and that's subtending those points. We don't really talk about subtending very much. I wouldn't stress it. The big thing is knowing central angles and inscribed angles. Central angles go through the center of the circle. Inscribed angles go to another point on the circle. Awesome. And we can have lots of inscribed and central angles on a triangle. So we're going to look at this right here. I'm going to show you 3 different inscribed angles. So I'm going to talk about points A and points E and the different ways I could connect to them. So the first way is I could go from A to B and then from B to E. And I could create that angle right there. Another way I could get from A to E is I could go from A to C to E and create that angle right there. And a third way I could do this is I could go from A to D to E, and I could create that angle right there. All 3 of those angles are inscribed angles. They're inscribed angles because they go from one point to another point on the outside edge and then back to our point E. Because they are all subtended by the same arc, meaning that they all are connected with this arc right here from A to E, they are congruent angles, congruent meaning the same. So looking at that, I could actually see, because I went from A to E on all 3 of those inscribed triangles, that all those angles are actually the same. They're all congruent. And we could do that with like our own diagram too if we wanted. So if we just like drew some points on a circle, let's say this is point A, this is point D. And I just wanted to go and start drawing lines. So from A to some point right here to this point right here. That would be the same angle I'm creating if I went from point A to, let's say, that point right there, and then back to D again. Those are both inscribed angles right here and right here, because I went to another point on the outside of the circle, and I went from A to D in both cases. So those would be congruent angles. I could do one more just for fun. So if I say went from A way out to D like that, and then down to D, that would create another congruent angle right in here. And again, those are all inscribed angles because I'm going from A to a point on the outside and then back to my point D. Awesome. Let's see some questions about this. So why are inscribed and central angles important? Like, why do they affect each other? The reason that they matter, they have a property that's kind of cool. So when you have a circle and you have a central angle and you also have an inscribed angle, what happens is your central angle is actually twice the measure of the inscribed angle. So central angle equals 2 times the inscribed angle. Oh, I didn't spell inscribed wrong. So for instance, if I look at this point, this circle right here, I have 2 points. I have point A and point C. I have an inscribed angle right here. It's inscribed because I went from one point to another point on the circle and then back to C. That's inscribed. And I also have a central angle. I go from point A to the center of the circle and then back to point C. This angle is the inscribed angle. This angle is the central angle. And the central angle is twice the size of the inscribed angle. So in this case, it would be 2V would be the angle of the central angle. An actual example, if we look here at this circle, I have 2 points. I have a point here. Let's just call it A for fun. And I have a point here, point B. And I have two different ways I can connect from A to B. I could connect from A to B by going out here to this other point on the circle, and that would create an angle of 50 degrees. Another way I could do this is by going through the center of the circle like that. My 50 is my inscribed angle, X is my central angle. Central angles are 2 times the inscribed angle. So if I was like, hey, what is the measure of that central angle? You could say it's 100 degrees. Perfect. We could also work this backwards. So I have 2 points here. I have A and B. I could get from A to B by going all the way out to C and then back down to B. Or I could go from A to the center of the circle and then over to point B. My inscribed angle is the blue one because it went to another point on the circle. My central angle is the 60 degree in the middle because that's the center of the circle. If I wanted to figure out what X was, in this case, it would be half of the central angle. Half being the opposite of twice, right? That's how I could, instead of doubling it, I could half it to go the other direction. That means X would be 30 degrees in this case. Perfect. You can draw your own example over here. I'll just draw one randomly. So if I had a point, let's draw a point here, A. Let's draw a point here, B. And let's get from A to B a couple different ways. So I could go to the center and then out to B. Or I could go to a different point, let's say point C. Let's do point C over here. And if I did that, I would be creating an inscribed angle. So out here to C, out here to B. And those don't look quite as nice as the other ones, right? Because my point C, my other point is kind of way off to the side. But I have an inscribed angle right here and a central angle right there. So if I actually had measurements of this, the central angle would be 2 times the inscribed angle. I would say that inscribed angle is probably about, rough estimate, let's say 60 degrees. So if this is roughly 60 degrees, the central angle should be double that, 120 degrees. Cool. We're going to see circles now that kind of have crazy patterns and points and different lines all over the place because we could put multiple points on the inside of a circle. You're going to see it can get kind of hard. It can get kind of confusing. But when we get there, we'll be ready to roll. So semicircles have another property. So a semicircle means half a circle. So if you had something like this right here, this is half a circle. Because you're using half of a circle, you need to understand that the central angle from one end of the circle to the other would be 180 degrees because that's what creates a straight line. Therefore, any triangle that you build that goes from one point of the semicircle to the other point of a semicircle will always create 90 degrees. So if you're going from one end of the semicircle to the other end of the semicircle, it'll always create 90 degrees. The reason that's happening is because of our double rule, right? You can see this angle is 180, which is the central angle because it went through the center. Right? This is through the center right here. So that means this should be half of 180. Half of 180 is 90. Here's another semicircle over here. So a semicircle is going from A all the way around here to point B. Because of that, any triangle I build that goes from A to B would be 90 degrees. So I have 3 different triangles here. I have from A to F to B. That's a 90 degree. I have from A to G to B. That's 90 degrees because it goes from one end of the semicircle to the other. And I have A to H to B. And that has to be 90 degrees because I'm going from one corner of the semicircle to the other corner of the semicircle. Cool. If I want to draw one more, let's just draw one more. So let's cut our circle in half like that. If I was to build some triangles in half of a circle here, so if I went from one end and then to the other end, it would always create a 90-degree right here. And it doesn't matter where I go. I could keep doing this. So if I went from one end of the semicircle to the other end of the semicircle, it will always create a 90-degree triangle. It's hard when you get really close like that, but that's a 90-degree. It'll always happen. We'll do one more just because, why not? Let's go from one end of the semicircle right to the middle and out. And you see, once again, we've created our 90-degree right here. Awesome. Let's try some questions. So in a circle, identify an inscribed angle and the central angle subtended by the same arc. Okay, so if I'm looking at this, my central angle is how I can connect from one point to another point by going through the center of the circle. So the center of the circle is here. My angle, if I look, is by going from B to O to C. That would create my central angle. We write that as angle B to O to C. The inscribed angle would be what happens if I go from B to the outside somewhere, like point A, and then back to point C. That would be angle B to A to C. Awesome. We have a couple more over here. We have a few different triangles we're going to have to do on this one. So this can be tricky. You have to find points on the outside that you can get from one point to the other by going somewhere else. So for instance, like if I started at D, I could get to point C. I could get there a couple different ways. I could go all the way out to B, and then I could go to point C. And that would create an inscribed angle because I went from one point to the other. Another one that I could create is I could go from point D and go to O, which is right in the middle, like that. And then I could go to point C. So I'm getting from D to C, but there's two different ways. One way is by doing the inscribed angle, going all the way out to point B. Another way is by going the central angle, which is going to O. So we could write these two different ones out. Let's do the central angle first. So that would be angle D to O to C. Now, typically, people would write that as angle COD, just because people usually go with alphabetical, like C comes before D. But that's the same thing as saying angle DOC. Same thing. The inscribed angle I just created was going from C to B to D. So that's angle C out to point B and then out to point D. Awesome. There's a few more. Let's try green. So I could go from A to O to C. And that would create a central angle. So that's angle AOC. I could also go from A to B to C. And that would create an inscribed angle because I went to another point on the circle. I didn't go to the centered spot. So that would be angle A, B, C. Wonderful. I'm just going to erase those because it's getting a little messy. And then we'll try to find a couple more. So another one, we could go from, how about A to D? Have we done that? We haven't done that. So I could get from A to D by going A to O to D. And that would create a central angle because I'm going through the middle. So let's write that out. Central angle, A to O to D. Or I could go from A to B to D. And that would create an inscribed angle because it was on the outside. I didn't go to the middle. Angle A to B to D. Now it happens that I did cross through the middle, but I didn't go to the middle as my point of like turning. I went all the way out to point B, then I turned and went to point D. Cool. That's central and inscribed angles. Let's try to fill in some numbers. So we're going to determine the values of the indicated angles. We have a question here. We've got a bunch of different lines and angles going on. We're looking for angle X. We're also looking for angle Y. Different ways that you can tackle this. Okay. One way that I would like to tackle this is by using inscribed angles and central angles. So there is one angle I'm given, it's 55 degrees. So I'm going to draw that. To get that 55 degrees, I went from A to C all the way out to B. And that's an inscribed angle. I want to try to find the central angle that would be linked up with that inscribed angle. So I need to get from A to B, but now instead of going to C, I need to go to the center of the circle. So I create a central angle. I'm going to go from A to the center and then out to B. These angles, the 55 degrees, is the inscribed angle from A to B. Y degrees is the central angle from point A to point B. We know that central angles are 2 times the inscribed angle. That means that Y should be 2 times 55 degrees. If you put that in your calculator, that means Y is 110 degrees. And I could fill that one in right now. Perfect. We now have another angle. So we have from A to D to B. That angle ABD is another inscribed angle from A to B. Just like this was an inscribed angle at 55 degrees, that's an inscribed angle up there connecting A and B. And we know that inscribed angles are congruent, meaning they're the same. So these two are the same. That means 55 degrees is angle X because it's also an inscribed angle connecting points A and B. All right, let's try point B over here. So again, we have a bunch of triangles drawn. I'm going to label what they're looking for. So if I was to read this question that says angle from A to O to C, that means you're looking for that angle right there. I'm just going to call it X for now. The other angle they want you to find is angle A to D to C. So if I went from A to D to C, that's that angle right there. I'm going to call it Y for now. So those are the two angles I'm looking for. Okay, finding those angles. Let's start with the purple one, the angle that I called X. If I'm looking at that, that is a central angle because I'm getting from point A to point C by going through the center of the circle. So what I want to do is I want to find an inscribed angle that also gets me to C. If I look, they've actually given me one. So if I went from A to B to C, that creates an inscribed angle and it gets me from point A to point C. Inscribed angles are half the size of a central angle, or central angles are twice the size of an inscribed angle, depending on how you want to look at it. So for us, that means that X must be 2 times the inscribed angle of 52 degrees. We throw that in our calculator, that's 104 degrees. Awesome. The other angle we have, y, is also an inscribed angle, and it's connecting A to D to C. But they both are going from A to C. We know that inscribed angles are congruent if you're going from one point to another point. That means y must also equal 52 degrees because they're both inscribed angles connecting 2 points on the outside of your circle. Okay, we got 6 more. Let's try this one. So we've got a few angles here that we're looking for. We're looking for M to N to P. So this first one, M to N to P, is this angle right here. The next one we have is angle P to M to N. P to M to N is this angle right here. And then we have angle M to P to N. M to P to N would be this angle right there. Awesome. Now, to solve these, we're going to have to somehow work with the angle that they've given us. So if you look, they've given us an angle of 68 degrees right in here. If I look, that is the angle that would connect P to L to N. That's an inscribed angle from P to N. All inscribed angles that get me from P to N should measure the exact same. That means that if I went from P to M to N, those are both inscribed angles. They should be the exact same thing. That means P to M to N should also be 68 degrees. So I can fill that one in. Awesome. Now we have to try to find these other two angles that I've labeled. When you get a question like this, it can be intimidating. It can be really hard to tell what angle is what. What we do have here is a semicircle. It might be hard to see, but I'll try to highlight it. So the semicircle, can I draw a semicircle? I cannot. The semicircle is created from going across like this and then around the outside like that. See my semicircle? And we know that any triangles that connect the two ends of the semicircle should always equal 90 degrees. So if I look, I do have a triangle here. I have this one that goes from P to N to M. That connects the two corners of my semicircle. Anything that connects the two corners of a semicircle should be 90 degrees. That means from P to N to M would be 90 degrees. That's the same thing as saying M to N to P. This right here is 90 degrees. Fantastic. My last angle I have to look for is this red one. This red one's tricky. I'm just going to call it X. I'm going to try to highlight that there's a triangle here that X is involved in where you can see the other two angles. So if we look, angle X is created right here. In that red triangle that I just drew. And I know that all angles in a triangle must equal 180 degrees. So if I know two angles, I always know the third because I can go 180 and subtract the other two. So I can subtract 90 degrees, as I can subtract 68 degrees. And I can put that on my calculator, and that will tell me what angle X is. If you do that, you should end up getting that 22 degrees equals X. Awesome. Point D over here. This one's tricky. It almost looks like 3D-ish, so this is going to be a hard one. We're looking for angle X, Y, Z. They've labeled them for us, so that's kind of nice. It saves us a little bit of work. Let's just see what we can find. Okay, so if we look, we have a couple of central angles given to us. I know they're central angles because they go to the center dot. For instance, I have a central angle right here of 100 degrees, right? And that's the angle that connects A to B to A. Sorry, B to the center to A. I also have another central angle down here at 140 degrees. That's the angle created from going B to the center out to C over there. Perfect. I do have a third one, but I don't know what it is. This is this third one right here, X, this third central angle. And that's the central angle that would be created by going from A to X to C. Now that X1 is actually where we're going to start, and it comes from a trick that we haven't talked about yet this unit. We did talk about it a long time ago, but I don't blame you if you have forgotten. That trick is that if you have a circle, which we do have a circle here right in the middle, you can see this circle right here. That circle should equal 360 degrees. And we know two parts of that circle. We know the 100 degrees and we know the 140 degrees. So if we were to subtract that away from the 360 degrees, that'll tell us what's the missing part of that circle. So we're going to go 360, we're going to subtract 140, and then we're going to subtract 100. And you should end up getting that angle X is 120 degrees. So let's put that in there. So those two central angles actually helped us find the third central angle of 120 degrees. Just because it created a full circle when we ended up putting all three together. Awesome. Now, our goal is to try to see if we can't figure out what some of these inscribed angles are. Let's start with Y. So Y is created from going from A to B to C. So I want to somehow connect that to a central angle. The way I create a central angle is by going from A to the center to Z. Oh, sorry, I keep saying Z to C. That central angle should be connected to that inscribed angle. And we know that central angles are 2 times the size of the inscribed angle, or the inscribed angle is half the central angle. That means angle Y out there is 1/2 of 120 degrees, which means it's 60 degrees. This guy right here. Wonderful. My last one is at angle Z over there. So I'm going to look at angle Z and I'm going to see if I can't figure out some tricks to figure this one out because it's going to be a hard one by the looks of it. The first thing I would do is I would try to see if it's an inscribed angle, central angle, what is it? I can't really tell. So if I take a quick look, I'm going to erase this. If I tried to build this thing, just because I'll show you what I think most people would try to do. I go from A to C to the middle. And that's nothing. Like that doesn't create any sort of angle for us, which is kind of tricky, right? Because that doesn't go from one point on the circle to the other outside point of a circle. That goes from one point to another point to the middle, which doesn't really help us. So our trick of central and inscribed angles just is not going to work on this question because that's not an inscribed angle. It's also not a central angle. Instead, we have to think of other things that we've done in this unit. So something that we have done in this unit is we've talked about isosceles triangles. Isosceles triangles are when you have two sides that are the same. So for instance, if I continue building this triangle, I look from A to the center, these two side lengths are the same. They're both radiuses. So if those two side lengths are the same, that means these two angles should be the same. Now, I don't know what the other angle is, right? I just know that these two angles are the same. I also know that all the angles in this triangle should equal 180 degrees. So that means that if I took 180 degrees and I subtracted the 120 degrees that I know, that means the other two angles must be 60 degrees when you combine them together. Since they're the exact same, I could tell you that this angle right here is 30 degrees, which means this angle is also 30 degrees, because that would add up to my 60 degrees total, which gives me the 120 in the middle for a total of 180 degrees. That's probably the hardest one that we do today, in my opinion, just because it's something that we had to remember from previous days about isosceles triangles and two sides being the same, meaning two angles are the same. Okay, a couple questions left. We got a whole bunch of angles here. Let's try to draw them out. So we have angle ACB. That's from A to C to B. That's this angle right here. We have angle B to A to C. That's actually not drawn yet, so I'll have to add it in from B to A and then to C. So I had to add that line just to be able to create this. B to A to C is right here. Then I have from A to O to C. A to O to C would be this angle right here, A to O to C. And then they want me to find angle C to A to O. CAO is this angle that they've labeled X right here. Awesome. The first thing I try to do is I try to look at what they've given me. So by the looks of it, what they've given me is they've given me a central angle. That central angle connects A to B. So if I can find the inscribed angle that also connects A to B, then I could work with that central angle. The inscribed angle that would get me from A to B would be if I went from A to C to B. That inscribed angle should be half of the central angle. So ACB should be half of 50, which is 25 degrees. Wonderful. So we got the first one down. The second one I'm going to look for is I'm going to look for C or B to A to C. And I'm going to use a trick that we talked about earlier. And that trick has to do with semicircles. So when I have a semicircle, which I do have here, if I were to go from C to B, that creates a perfect semicircle. That means any triangle inside of there is a 90-degree triangle. So when I go from B to A to C, that makes a 90-degree triangle right here. That means that's 90 degrees. Wonderful. The next one I want to look for is A to O to C. To get A to O to C, I'm going to use a trick again. I'm always using tricks, it seems. And that trick is that if you're on a straight line, that straight line should be 180 degrees. I know that part of that straight line is 50. They've given me this part of the straight line. I don't know that other part. The way I can get it is by going 180 degrees and subtracting 50 degrees. And that would tell me that the missing chunk is 130 degrees. So from A to O to C, right in there, right there is 130 degrees. And that's because that's a straight line, and straight lines always have angles of 180. My last one, I have from C to A to O. To do that one, I'm just going to relabel I'm going to use my trick that 3 angles in a triangle should always equal 180. If we look, we have 25 degrees, we have 130 degrees, and then we have the purple one that we don't know. So that means if I go 180 and I subtract the other 2 angles, which is 25 degrees and 130 degrees, it will give me my last angle of X. That should be, I think, 25 degrees. 180 minus 130 minus 25 is, 25 degrees. Awesome. F. If you want to try giving one of these a shot on your own, go ahead. You could try to give F a shot on your own, or you can move down and try the other 2 on your own as well. I'll step you through them again. So for this one, we have a bunch of different angles they want us to find. They want us to find ACB. From A to C to B is this angle right here. They want us to find D to B to C. That's this angle right here. They want us to find A to X to B. And they did note that that is not in the center of the circle. So A to X to B is right here. And then A to X to D, which I'll do. Oh, sorry. I keep meaning to underline these and I forgot. I'll do in blue. A to X to D. AXD is this one right here. In blue. Okay. Let's try these. You'll look at these right away and you should hopefully notice there's no central angles. Everything they've done is an inscribed angle by the looks of it, or it's just another angle in a triangle. I know none of these are central angles because none of these actually went to the middle or the center of the circle, which was labeled right there in the middle. So what I'm going to do is I'm going to look at what they did give me. And I'm going to see if I can't link it up to something else. So if I look at this first one, which I'm going to do in green, let's look at 32 degrees. That 32 degrees is how I connect from A to B. And I know inscribed angles are all the same. So if there's another way I could connect A to B, that inscribed angle would be the exact same thing. So if I look closely, I notice that I could get from A to B by going to C. That means these 2 angles must be the same thing because they're both inscribed angles that get me from A to B. So that very first one must also be 32 degrees. Awesome. Let's label that in there. Like that. Now, if I look at my orange one that's missing, I notice that I have a triangle. I know 2 angles. I could always find the third. So I can find that orange one by going 180 degrees and subtracting the 85 from the middle and subtracting the 32. And that will give me the orange one. So I go 180 minus 85 minus 32. That orange one is 63 degrees. And that completes that little triangle up there. Okay. Next one we can figure out. Let's move on to the red one, because the red one I'm going to use one of my favorite tricks. And one of my favorite tricks is that we have a straight line right here. And straight lines should always turn into be 180 degrees from one end of the line to the other end of the line. If this part is already 85, I can find the other part by going 180 and subtracting 85. So 180 minus 85 equals 95 degrees. This other part must be 95 degrees. And I'm actually going to use that trick again to now find the blue part over there. So if I look, I have another straight line right here. That means from one end of the straight line to the other end of the straight line should be 180 degrees. If I go 180 degrees and I subtract off the 95 that I know now, I get the 85 on the other side. So my blue one is 85 degrees. My red one is 95 degrees. And I'm using that trick that straight lines, if you were to go from one end of the straight line to the other end of the straight line, has an angle of 180 degrees. Cool. There are other ways to do questions. So if you're looking at this and you're like, oh, but you have an inscribed angle right here, and you do something else and you get the same answer, that's fine. You can do that, and that works perfect. Okay, over here, angle X. Oof, this is going to be a hard one. So if you're looking at angle X, again, it doesn't really look like they've given you much, but they have. They're also kind of using our trick of 360 degrees for a full circle. So the first thing I would do is when I look at this question, I would immediately say, okay, if this is 240 degrees, then the other side, if I was to complete it, should add up to be 360. So the first thing I do, even if it helps me or not, is I'm just going to fill that in because extra information is never bad, right? I'm just going to say, okay, that must be 120 degrees. It must be. Now that 120 degrees, it might help, it might not help. Again, extra info, it just doesn't hurt. Now let's try to see what the question's asking us to find. So the question's asking us to find this angle X right here. That's what's connecting if I were to go from, let's call this A to B. And that's going from A to there to B. Now, we know that that is an inscribed angle. I'm just going to call that point C. And inscribed angles are half of the central angle. But what is the central angle here? What most people want to think is that 120 is the central angle, but it's actually not. So the central angle here is from A to the middle to B, but it's this angle right here. The 240 links up to this one. The reason being is the arc that connects those 2 points. So when you're talking about point A and point B, the arc that connects them is this arc length right here. Therefore, when you're talking inscribed angles and central angles, you must be using the same arc, opening up to the same arc. So that 120 degrees is not the central angle. 240 degrees is the central angle. And we know that I want to change to blue. We know that the inscribed angle is half of the central angle, which also happens to be 120 degrees. So make sure on a weird question like that, and you're comparing inscribed angles and central angles, the central angle has to open up to the same arc length as the inscribed angle. 120 degrees was opening up to the minor arc length. Okay, last one. I think this last one. Yeah. So we got a bunch of different triangles labeled out here. Again, these ones are all labeled for us, right? Yeah, they are. That's wonderful. So the way I would start this off is by looking at what they gave me, seeing if I can't work with it. So if I look at this, I have a 56 degrees right here. That 56 degrees is connecting this point to this point, right? If I was to draw that out. That would be an inscribed angle. First thing I'm going to do is check to see if I can't find the central angle that would also connect those 2 points. The central angle that would connect those 2 points is right here. That would be angle B. So that means angle B must be 2 times that inscribed angle. So let's do 2 times 56. That should be 112 degrees. 112 degrees. Awesome. That's because central angles are double that of the inscribed angles. Awesome. What else do we know? So we have that inscribed angle of 56 degrees. Let's see if we have any other inscribed angles that we could look at. So if I look at my point over here, this red point randomly, and I went up here and then back over to that other point, I notice that I have another inscribed angle that would get me to the same point. Inscribed angles that connect the same 2 points on the outside must also be the same. That means this must also be 56 degrees. So we can put 56 degrees in right there. Awesome. What else can we do? We could look at my favorite trick. My favorite trick is that if you have a straight line, like we have right here, this is a straight line. The angle on a straight line should be 180 degrees. So this should be 180. If we already know that this is 112 degrees, then we go 180. We can subtract away the 112 degrees to give us that missing angle over there. Throw it in your calculator quick, and you get 68 degrees for angle C. I'm just going to label that. Give me a second. Try to clear off some of my work. So we now know, sorry, I erased angle A by accident. That was 56 degrees. Angle B was 112. Angle C was 68 degrees. Awesome. And then we have angle D over there. Angle D is going to be a tricky one. The way that we're going to get angle D, and again, there's other ways to do it, but I'm going to show you how I would do it, is I would recognize that I have a semicircle here. I have something that cuts everything in half. So if I was to draw a line right through the middle, I can cut that circle in half and have a semicircle. That means that if I was to draw a triangle connecting one end of that semicircle to the other end of that semicircle, it should equal 90 degrees from here and here. Well, I know part of that 90 degrees. Part of that 90 degrees is 56. If I want to know the other part of that 90 degrees, I could go 90 degrees, subtract away the 56, and that could give me 34 degrees as my missing side for D. Awesome. Again, I repeated myself a lot on the last video. Circle geometry is hard. It's one of those things that you're just going to have to practice a lot of until you can almost see what's going on. And it'll like pop out to you. And there's a lot of rules. And you just have to honestly practice them until you get so used to looking at circle geometry, you can see how things work out. All right. Best of luck on your practice. If you have any questions, make sure to ask your teachers. We can help you out the best we can. Best of luck. See you soon.